Hello there. Okay, so last week I did a whole bunch of refactoring in the Showtime application, and it was mostly to introduce reader TIO as a kind of app structure. So every function that needed to do any kind of IO got given the new app type, and it could use lift IO to perform IO actions, and it could also get to the app environment. So I didn't need to pass the app environment around as a special extra variable or extra parameter. Um, that's all cool. To make sure it still worked, I had to manually test all of the different functions. So basically run all the combinations of the functions I had in my application, and that felt kind of wrong. There should be some automated tests covering this. So I've been kind of thinking about this throughout the week. I didn't really intend to come back to it today, but it's nagging at my mind, so it's probably better I get it done. I want to write some automated tests, but this kind of unravels, it doesn't unravel, it just opens a whole bunch of other stuff I need to do. There is some Haskell stuff in here, but there's also just some general design and structuring things that I think I've gotten a little bit wrong or will need to improve. So I have this storage class, and when I'm running the tests, I want to swap this out and replace it with a mock. It just stores the stuff in memory, and then I can write some assertions on that. And like in theory, that should be quite straightforward. I think I haven't done this before, but I think it should be quite straightforward. I should be able to create a type class that has this kind of interface. So it'll have functions for loading and adding and removing, and then I'll just implement that type class inside this concrete implementation, and I'll write another one for testing, which will have the same interface. Basically, I'll implement these three functions: so load, add, and remove. And then inside append, I can just start to pass. I can set up the storage inside append. So when you have a function, maybe something like this, something that's using the underlying storage. Actually, let me find a better example. Here, loop participants, for example, something here which is using the underlying storage rather than hard coding statically the storage class is going to use. I can grab the storage value instance, I don't know what it'll be, out of the environment that we're passing in, and then I can use that to call load, because load will be one of the things available on the storage class. And then that's kind of cool. But then I was thinking a little bit about this interface, because it takes a file path, and file path makes sense when I'm storing it on disk, but it doesn't really make sense when I'm storing it in a database or in memory or whatever. So I want to make this a bit more generic. I'm not entirely sure how to do that or what I want to do. I'll think about it as we go. A couple of things I'm maybe thinking of. One is you could pass in, instead of a file path, you could pass in like a storage type or something that indicates whether it's a host or a participant or a topic. And then this could use that knowledge to look up in the environment and get out the name of the file that we're going to store in. Or we could just pass in the string host or the text host, and we could use that as the file name. And we could add it to sort of the base file path that's set up in the environment, and then just assume that if it's hosts, it goes in a file called hosts, and if it's participants, it goes in a file called participants. And then if I do like a database layer, it could say if it's host, it goes in a table called host. So that's one thing I may be thinking. The other thing maybe is that we can create a closure over. We have a function which takes the file path as the first argument, and then we can set up. Actually, let me just kind of sketch this out. So kind of what I'm thinking is we have a function called store host, and that would go. Sorry, it would just be store. In fact, it'd probably just be add. Let's call it add, and it would want some kind of Not really. Okay. Let me. So imagine we've got a function called add to file, and as we go from file path to I guess a storable. So we'll call this S, and it will run under the app or under IO. Doesn't really matter. And this S needs to be a storable thing. So we could have a signature a bit like that, and then we could have our type class called storage. And inside that class, you could have a function called add, which goes from an S in app. I'll worry about the S later. And then you could have something like add to file. You could implement it. So what's I've just got the syntax to implement a type class. Hang on a second. Oh, my mind's gone blank. That's annoying. Instance is what we're looking for. Sorry. So there'll be instance. This special storage, right? On file storage, and then you could have add, which goes from S to an app. It's going to be something like to file, then hosts. Wouldn't quite be that. That's not going to work. We don't know it's hosts. Okay, maybe that's not going to work. Maybe you'd need something like add hosts, and then you could create a closure. You could say it's add to file hosts, and wouldn't be in the class anymore. It would just be something inside append. Okay, there are a few different ways we could approach it. I don't know which one I'm going to go for at this point. But I do know I'm going to want to start to pass something down from this top level. So when I'm in main, up here, when I'm running reader T, I'm passing in result of load config, and that's passing back an append. Currently just these file paths and the number of participants. And I probably want to add some kind of storagey thing here. Okay. So I'm gonna start with that. And I'm gonna start by I think I'm gonna start by creating a type class for storage. So we have storable, but let's do another one, which is storage. And at the moment, I will just implement load. Load is going to go from load hosts. Let's keep it simple, right? Load is going to just have this type signature. It's going to be storable S, and it's going to go. Because I really don't want to be passing the file path. I want it to be that. Okay. I'm gonna have some name clashes for a bit. I'll come back to it later. This is going to be storage. I'll export that. So it's going to take given some S which is storable, it's going to go from X to a list of S's. Something like that. Okay, and then in the append, we should be able to import storage as S. Probably want to qualify it. Qualified in post positive position. For qualified, storage is S. Storage imports the app because everything runs under the app. That's tricky. Maybe this shouldn't be aware of the app at all. It should just run under IO. Okay, that's going to get difficult to implement. So let me create a new module. In fact, what I might do is rename this as file storage. And then I'll create a new module called storage, and that will just contain this type class for now. So in here, I'm going to have storage, and I'm going to have file storage, which actually implements that. Okay. So we go to storage again, and then rename this to be file storage. Not try again, but not Haskell this time. Rename file storage, and here we say file storage. A whole bunch of things will be broken, but let's also in here create the storage class. Let's say module storage. It's running yet. And nothing. Okay, let me jump through these. So that one's broken. Oh, they're all broken because I've broken Cabal. Maybe it'll be okay now. Okay. So here we're not going to import storage, we're just going to import file storage for a second. We'll come back and change these later. Oh, storable is not in there. So in class storage, we'll import file storage as S. And get rid of that. Restart LSP again. See if it works this time. It does not. Okay. What's the other error? Here. So in topics, we'll import file storage. See, I'll restart now. Still not going to run. There's still errors somewhere else. Topics of storage. Okay, this one needs file storage as well. I've only got this one left. So it seems I need to fix the library and then restart LSP in main when the library is working. Okay. So all of that, so I can create a new file called storage, and this is where I'm going to put my new class. So I'll say class storage x where, then we can say add, and this where we want are storable. Let's not worry about storable for a second. Let's say the type of this goes from x to IO of A, where A could be anything. And we'll export storage from here. Let's not do A because that's the wrong thing. This is going to be load. But now I'm thinking about type classes in the same way as I'm thinking about interfaces in Go, and they're not the same thing. You don't pass in a variable or an instance, a value of a struct to implement these things. Well, it's going to trip me up in a second. Anyway, let's go back to app. So here I now want to import storage again. Import qualified storage. Yes. Okay, and then here we're going to have some kind of storage, which is of type s.storage, but it can't be of type s.storage. So I think maybe what I want to do is say this. No, you can't. Can I say for all at this point? I can, don't ever wanted to. It just said adding rank n types, and I don't know if that's exactly what I want to do. Oh, okay, we'll see. For any x, if x is storable, then it can be used for this storage. Okay, and then load config isn't quite what we want anymore, so I'm going to rename this to be create env, new env. Renaming unsupported, good. New app env second, and then this will be new app env. They call it make env, don't they? I think that's the standard in Haskell. I think. Okay, and then when we're creating the app env, I want to take s.storage and go from an s to that, and then we take the storage here and we put it there. Good and bad. I don't mind expect x, but that's type s. Tricky. Right, because I don't know what I'm doing. It's a rigid type variable bound by type expected by the context for all x. If x is of type storage, then x. Okay, and then this is s rigid type variable bound by the signature blah. So for all s s.ioapp. I thought this and this were the same. Like the letters are different. Does that matter? I would hope not. Nope. That wasn't it. Be more explicit about this, but I don't think it'll help. Less that still does not help. Oh, got multiple S's here. Didn't matter. Okay, that was not the problem. Okay. I wonder how a user type class here. Can I say s.storage s say here for all s. This doesn't feel like I'm going down the right route. But the compiler stopped complaining. Okay. So what I'm saying here. Got a new field in our record called storage, where for any S it has to implement storage. Okay. Back to here, this is no longer load config, this is now make app env. And we can say env comes from make app env, and it needs something. And then we want to create a file storage of some kind. So something that implements the storage interface, the storage type class. Okay, so we go to file storage. How's that going to work? The type of load is xioa. So I still don't know how I get my file path into here. So let's try the same way. So instance. Here. Let's create a new type for this called file storage. Then we can say instance storage, file storage. We need to import this. And then thing we had load. And let's just set it undefined for a second. Logos X to IOA. Look at how I implemented in cast. How did I implement the interface? Load of whatever. I need to pull in all these. Okay. How do we load that? I wonder if we can give it some kind of mapping between the type of thing that's being stored. And the path to it. And one of us could take like a map. Some kind of map from text to text. How did it not map? I need to containers 066. Containers 066. So import map. Using current load. Okay. Because there are two different loads. So let me import qualified storage as S. And then we can say s.storage is that. And then s.load is that. You cannot do that. Oh, okay, that's enough to get rid of the ambiguity. Okay. So we create something which does this kind of mapping from the type of data you're storing to the place where you store it. We go back to our definition of load. It's going to go from the type of the data let's call it data type, and that's going to be host or participant or topic. It's a bit annoying because now when I add something that's going to be stored, I have to come back to here. That doesn't feel super right to me. But otherwise, if you're calling load, where are you loading from? You need something that tells it where you're loading from. And then you could pass in a string, but then I'd rather pass in a proper type. So go x to data type to that. Okay. So now load is going to go from the file storage itself, and then the data type, and return something. So we can say let's grab that for a second. We should need to lift IO because we're in IO. We don't know what the path is. Oh, it's a list of A's as well. Although it shouldn't care. I mean, A should be allowed to be a list. Maybe it's not. Let's explicitly say it's a list. Okay, and then path is going to be, we need to look it up. m.lookup map import data dot qualified data map as m. We're going to look up our key, which is E in our map. Now, unfortunately, this is going to give us back maybe a result. So what we then need to say is, if it's not in our map, but our map doesn't go from text now, it goes from s.data type to a file path. Okay, so now we can look it up. It still gives us back a maybe. And what do we do if it's not there? Right. I'm going to move into this function. Sorry, I'm just going to change this so it matches. The load is going to go from a file storage now and the type to some result. I did that so that I can write case m.lookup. Oh, and then here we have the path. We have the file storage and the type. So we're going to look at the type in the file storage. Yeah. So if this is nothing, use error for now. They cannot load data of type, and then t will derive show equal here. Okay, and if it's just a path, then we'll do this. And then here we can say, so load has got some kind of storable type. We can just call load, passing in storable type. Load equals load. Good. Okay, now we can't look up this. So we're going to say get file paths. User type that. And then here we can call get file paths file storage. Okay. We derive ord in here. Apparently we can. Okay. So now we're at a position where it expects this returns something which is storable, and that storable is important for the unmarshalling. But in this type class, it just returns anything. So what I'm going to do is grab this and move it into storage, because I'm going to use it here. So now inside this type class, I want to make sure the A itself is storable. And we'll pull in, and we'll export from here. So we have storage, storable, and the type of data that we're storing. Okay, back to here. So we will just import that from storage. Can't see my list. Storage S. We can also import storage, storable. Storable and all its functions. Okay. Right, so now in theory, if I create a file storage, I give it a map of these types to the file path, then I can use an instance of this as my storage, and I should call load on that storage rather than calling it directly as concrete implementation. Find something like make storage, make file storage. Not worth it, because it doesn't do anything that I couldn't do by just passing the map indirectly. don't even know if a map is the right thing here. It feels like it should have. Oh no, it's going to say it should be like a data type where it's got the mapping for each of the different types of data. But I can't go. The constructor that wouldn't be of type data type. It wouldn't help. I'm not sure that's clear, but in my head it's fine. Map is probably fine. The thing it knows about map is I don't know that all of these keys are present. So it doesn't feel like it's quite correct, but it's pretty good enough. Okay, well, export file storage from here. We won't export storable anymore. It's not in here. And then we should have a bunch of places which use storable but don't know what it is anymore. So here, we import this. Okay, and then we can say import qualified file storage as fs. And we'll just make these things fs for now, although the whole point of this is to get rid of the load. Just to get rid of like calling file storage directly, it should just grab out the app. Okay, I'll come back to those in a second. Let's do the next file. So instance here, we're going to just pull in storage as S. Okay. Right, so this fs.load doesn't work. So what I actually want to do is now get the storable thing and call load on it. So we can ask for storage, and this gives us back the same as type. So I'll do this for a second. We ask for storage. If I put it here, okay. You just escaped type variables. That's going to be complicated to fix. We can get our storage back. When we have our storage, we can call load on it. Load takes an extra argument, so load will be s.load. s.load. I want the one for ask, I want the one for load. Let me just go and check load again. Sorry. Got what the type signature is. So load, given some storable thing, that's going to be my storable thing x here, and the data type. Oh, that's annoying. No, because they order these arguments. We can say storage itself, we'll just ask for that. And then we can call load with excuse me. We can call load with storable thing, and then specifically hosts. Storage class, this data type, I call it host. But I still can't do this. Use pattern matching syntax instead. I don't know what the pattern matching syntax means. Quite nice to give an example. Okay, we just go back to the application for a second. I think it's saying that this S cannot be returned here. I think that's what it's saying. So maybe I can go and ask the internet. What I'm going to ask it, I want to ask it how to use type class in a record in Haskell. So Haskell type class in a record. Type class constraint. Maybe spell it right. Will it matter I reorder the words? Okay, so change command from data type to type class. I express this. And add the constraints and features like this. Okay, so maybe this is the wrong way of thinking about type classes. This is not about type class. Right, do this then, because I want to have something in this record where that thing is any type to implement storage. So maybe lifting it to here made my typewriter go away, but maybe that was misleading. Because what I really want to say is storage. Has it got just a fix? It does not. And then I've been here before, so I said for all S that. And it says maybe you want to use rank n types. I can add that, but then I get some other errors. I don't think I really want rank n types. So I could try searching rank n types in record. Using rank n types to pull the record structure. Nope. Okay, let me get rid of the record for a second. So here's storage there, and here, and here. Okay. And oh, we haven't fixed something yet. What else? So in storage, I still have this storage thing, storage class. So we'll be using it here. So what if I just set this to storage S, and then from S to there, and then put storage in there. Okay, and then we want to call load on storage. That the whole thing needs to be lifted into I/O because we're running under the app. No, oh, because my lift over been pushed down a little bit. Okay. I mean that kind of works. So why can this? Why can this not go into a record? I wonder. Storage S. We're not going to ask for people file path anymore. We are going to take storage, an argument, and we're going to lift IO s.load and get the storage. I want to type. So this also needs to take storage. Okay, but I really don't want to be passing this extra argument. It's the whole point of having the environment. So maybe a name conflict for storage, record function storage. Maybe. Let's find out. I don't think I did name clash here. Let me go back to application. Okay, so if I have something called storage here, and it's a type role s storage s, and down here we need to take something storable. So S1 here is not constrained by anything. So types by this, and S variable type bound by that. Plus S. So hopefully in here we can say role s dot storage s, and you get the same error. So I can't make this error go away. I'll try Googling actually. This might be a bit of a strange name. Oops, not that. Can't wear that thing. So here, stg is that what you were suggesting, Bernd? So we thinking that the s here or storage here clashed with either the type or the function name. But it still seems to have a clash at this point. It's quite delay in the chat, so it'll be a while before I find out that's what you meant. Meanwhile, I will look at this. So data file, similar kind of problem, I guess. So rank 2 times. And I got a function here. So they pull in GDTs, which I didn't do. But here they put a constraint on the type of func. when it uses func, they put a constraint here. I better just avoid it. Let me just try what they did here. So I'll pull in JDTs, see what happens. Not JDT. JDTs, plural. Okay, I'll drop this. And then here, drop that. And now I'm getting a warning, an error, sorry, not in scope type this. So I don't think this is radically different. Ah. Where? Okay. So JDT and record. Currently stuck, I think. Append S. Not that. Haskell JDT's records. I've already used JDTs before, so I don't know what I'm doing. Heading here about records. Oh, it is. It's colon, and then the record type. Well, that sounds complicated. So everything starts as field F must have the same result type. Num and arg. In a single name. Very confused about that. Okay, but let's. So can we do the record syntax here? It's going to be where? Record syntax is illegal here. But I think it looks it needs to go to something. It needs to be app env something. So now we have FMS. No, this is just as bad. Probably getting worse. Okay, they've got other debts at this point, and time's getting on. So what I'm going to do is leave it broken. During the week, I might actually cheat. So I'm trying to learn Haskell on these live streams, but I might take a bit of time in the week and look up where I should be going with this. It might be the whole approach is wrong. It could be that maybe I am trying to use a type class like I would use an interface in Go or Java or something. And that's not what I should be doing. I might say there's a better way of having something replaceable so I can swap out storage for different implementations and have it in some kind of environment or some kind of reader. The other option is to give up on reader altogether and have a look at effectful or some other effect system, but probably effectful will be the way I go. And let's get some examples. Somewhere there are some examples of this. But not here. Going down an effectful route might be better, but I don't know. So I'll have a look at this in the next week, and then when we come back next week, hopefully I'll have more of a clue of what I'm doing. So thanks for watching along. Sorry, it was a bit of a dead end, but I've maybe learned how not to write some Haskell, which I guess is some progress. And then hopefully next week I can find the right way out of it. Yeah, thanks for watching, and hopefully see you again next time. Goodbye.